Hey chemical engineers, I'm Tinotinda Terra, a part 3 student at NUST University, undergraduate, right? So this is mass transfer 1B. I wanted to help the current part 2 guys to solve this particular problem because it was difficult for me when I was part 2. So I thought I would take this opportunity to help you guys, right? Let's read together through the problem. It says 0.4 kgs of seashore sand containing 1% by mass of salt is to be washed with 0.4 kgs of fresh water running countercurrently to the sand through two classifiers in series. It may be assumed that perfect mixing of the sand and water occurs in each classifier and that the sand discharged from each classifier contains 1 part of water for every 2 parts of sand by mass. If the washed water is dried in a kiln dryer, what percentage of salt will it retain? That's the first question. Then the second part asks, what wash rate would be required if a single classifier was going to be used in order to wash the sand to the same extent, right? So let's jump through the problem together. Okay, so let's just draw the schematic in order to understand the problem statement clearly. Right, so we've got 2 classifiers in series. I'll call this 1, I'll call this 2. So we've got water, clean water entering as the overflow and leaving again as the overflow and coming out of classifier 2. Right, hope this is clear. So we've got on the underflow, we've got the sand and the salt like this. Right, so that is how I understand the problem. Right, so here we've got H2O, which is equals to 0.4 kgs per second. Right, sorry, I just wrote, maybe it wasn't clear to you guys. I wrote this, yeah, 0.4 kgs per second, right? Then we've got it is just clean water. We've got no sand. Then here we've got sand, which is 0.4 kgs per second of sand, right? Then we're told that 1% of the sand is water, right? It says the sand contains 1% of salt, so we can say 1 over 100 times 0.4 kgs per second. So it's not like the problem statement is not saying 1% of the sand is salt. It's saying the 0.4 kgs of salt contains a mass of salt which is 1% of it, right? So it means that the sand is sand, then we've got on top of the sand we've got salt, right? Which is what 0.004 kgs per second. 0.004 kgs per second of salt. So assume that we have got no water attached to the incoming sand. So there's mixing here. Then here we've got sand as well. So sand does not dissolve in water. So let's keep that alive in our minds. Kgs per second. So from classifier 2, we still have this amount of sand. Let's call it sand. Then here also we still have 0.4 kgs of sand leaving classifier 1. Hope this is clear. So now we're told that for every 2 parts of sand, so sand to water, the ratio, sand to water, we have got 2 is to what? 1. So here, now we say, how much water do we have here? Since we have got 0.4 kgs, so we've got water, which is equals to 0.2 kgs per second. Hope it's clear. So how much? So here let's just go back to here to the exit, the final thing which we want to look at. So we've got x kgs per second of salt. So we don't know. So how much water do we have here? We have water. We have got 0.4 kgs of sand, which means we say we've got how much water? 0.2 kgs of sand. We're sticking to that statement which is telling us that for every 2 parts we've got 1 part of water, right? So hope this is clear. Sorry my camera wasn't seeing that part. So here I wrote 0.2 kgs of water, right? I hope you see. Okay, fine. Let's continue. So now, before we go any further, okay, let me just write so that you may see 0.4 kgs per second of water. So now let's do our water balance, right? So if we're doing a water balance, we treat this system as a whole. So we look at the exit and the entrance, exit, entrance, right? So we've got 0.4 kgs of water entering, then we have got 0.2 kgs of water leaving. Here we've got no water, so we assume that how much water is leaving here? 4 minus 2, we've got 0.2 kgs of water leaving here, right? Hope this is clear. Sorry, this is the part which I wrote. Then here, how much water do we have? Let's look at classifier 1 as a single unit and do a water balance. So we've got this amount of water entering here, which is 0.4 kgs entering. Then we've got 0.2 kgs entering. Then here we've got 0.2 kgs entering, leaving. So now here, how much do we have? 0.4 plus 0.2, that's 0.6, minus 0.2, that's 0.4. So here we've got 0.4 kgs of water leaving classifier 1, entering here. So when it enters here, we've got 0.2 leaving and 0.2 leaving, right? 0.2 leaving and 0.2 leaving. We're looking at water, right? So the sand is constant. So now we're asked to find how much is this salt now when it's dried. So how much is X? So we're told that there is perfect mixing which is occurring in each classifier. So now here, looking at classifier 1, we've got salt. We don't know how much the amount of salt is in classifier 1, but we know that we've got 0.2 kgs of water which contains X amount of salt, right? And here now we've got 0.4 kgs leaving this classifier. It contains 2 times this amount of salt. So we're told that, so from this analysis we can simply say salt is what? 2x kgs per second. This is salt leaving this amount of classifier. Sorry, I wrote here 2x kgs of salt leaving classifier 1, because here we've got X amount, because we know that 0.2 kgs is half of 0.4 kgs of water. So this, if perfect mixing is occurring, so we know that this contains double this amount. Hope all is clear. So now here, now we know that this amount of water and this amount of water are equal, so they contain equal amounts of salt. Clear? Fair enough. Okay, so let's do a salt balance. So salt which is entering from the overflow is 2x, and salt which is entering from the underflow is 0.4 kgs. So how much salt is here? So because we know that these amounts are equal, so they share salt in the same ratio. So let's do the salt balance in classifier 1. Right, so let's go together. So we've got on the underflow, we've got 0.004 kgs per second, plus from the overflow we've got 2x amount of salt. How much is this now? So you just have 0.044 plus 2x plus the amount of salt which is entering here in classifier 2, okay, here. So now how much? So let's just divide it by 2. Why am I saying divide it by 2? Because we know that the ratio 1 is these water amounts are equal, so they share the salt equally. So the salt which is here now, which is leaving classifier 2 and that are the same, so we just divided this by 2, right? So if maybe this was 4 and this was 8, we would distribute it equally and share it according to the ratios, right? So but in this case they're equal. So now salt leaving classifier 2 is equals to half of this, which is now 0.002 plus x. So here we've got 0.002 plus x kgs per second of salt. Right, sorry, this is it. Now what else we do? So we want to find out the value of x. Right, find out the value of x. So now we do a salt balance. Right, let's do a salt balance. Okay, so now let's not waste time. Let's just do the salt balance for the overall system. Right, and we know that this is our overall system. Right, sorry, yeah, now it's clear. So we look at the inlet. We look at the inlet of salt, which is here. That is where salt enters. Here we've got clean water, salt does not enter. Here we've got water, we've got salt, which is equal to this amount of salt, right, which is 0.02 plus x, because we said these are equal, so they contain equal amounts of salt because perfect mixing occurred, right? So and then here we have an outlet of salt. So inlet, inlet, outlet, outlet. So let's do a balance, right? So salt entering from the underflow of the classifier 2, we've got 0.004, which okay, plus 0 from the overflow here, 0 with 20 of salt. Now here, how much salt do we have? It is equal to this one. So we saw 0.002 plus x. Oh, sorry. Yeah, no, I'm not sorry. It's okay. That is it. Then here. So let me just write this so that 0. It's okay. Fine. You just keep it in your mind that this amount of salt is equal to this one, right? So here, the outlet of the overflow, we've got this. Right, we've got this, then plus, so let me just do it fast. 0.04 is coming from the underflow sand, then 0 from the overflow inlet in classifier 1. You know that there is 0. Then here we've got the overflow outlet, which is here. This is the amount of salt which is equal to that one because of perfect mixing. Then here we now add the exit underflow, which is here, okay, plus x, right? So plus x. So now we have 0.02 plus 2x, 0.004. So now we let this go to this end. Now we've got 2x is equals to what? 0.002 because we subtracted, right? Let's go together. So now we've got x is equals to 0.001 kgs per second of salt. I hope you understood. Please follow again and again. This is the answer of salt. So now, this is salt which is leaving here. We know that 0.04 was the salt which was entering. Now, how much, if we are equating this to the overall amount of solids, what percent is this? So we say 0.001 over, we know we've got 0.4 kgs of salt, of sand, plus 0.04, right, amount of salt. Then, so here, times 100, sorry, so that you get the percentage. Okay, I'll punch my calculator. I made a mistake, sorry, this is the mistake I made. We should say 0.001, right, over 0.04, which is the sand which does not dissolve in water, plus 0.001. We shouldn't say 0.4 because now we're asked what is the percentage of what, of sand, of salt in this. So in this, the salt is now 0.001. It is no longer 0.004, right? So if we're asked what is the percentage of this, maybe we'll choose 0.004. So now, sorry, bear with me, I made a mistake. 0.001 over 0.4 plus 0.001 times 100. Then we get what? So we get 0.249%. Well done. We've answered this part. Okay, now ladies and gentlemen, let's continue with part B. What did they ask us? So part B is saying, fine, we've got now one classifier, right? Initially we had two, now we had one classifier. So we've got the the underflow inlet, which has got 0.0, which is 0.4 kgs of sand, and we've got 0.004 kgs of salt. Right, so let me just say sand, and here let me say salt, so that you may follow clearly. Then the leaving underflow, we know that sand or curd does not change, so it's 0.4 kgs of what? Sand. Then here we've got 0. So now wait, what is the question asking us to find out? What wash rate would be required in a single classifier in order to wash the sand to the same extent? Okay, so now we're not told how much H2O we need. We're asked to find the H2O kgs per second. Right, so this is what we're looking for, the H2O. Right, so now they're telling, okay, so to the same extent, meaning to say we have how much salt do we have now? The same amount of salt, that is salt is 0.001 kgs of salt is what is produced, because we're washing, we want the same amount of salt and sand. Right, so this is the after being dried, we only left with salt and this. Right, so this is the salt, this is sand. So now we're told find out the water amount. What's the water? So now we know that we're told that for the ratio of sand to water is 2:1. Right, so now here probably we have got, not probably, in fact it's kgs of water. Here we don't have water, so now water is living here. We do not know how much water is living here. We need to make a water balance and a salt balance. Right, okay, friends, what we'll do here is that since we know that there is perfect mix, let's just call this one classifier. Since we know that there is perfect mixing, right, so here we've got salt, and we know that salt does not enter from this part, it only enters here and leaves here and there. So how much salt do we have here? Now we have 3 parts, because this initial salt was this, and now here we've got this amount of salt, so the remainder is here. So now we've got 0.003 kgs per second of salt. Does that make sense? Right, sorry, I wrote there. That is the amount of salt which is here, because of the salt balance which you have done 0.04 minus 0.001. Right, that's this 0.004 minus 0.001. We've got 0.003. But because we know that there's perfect mixing, meaning to say the water amount should be, let's say until here we know that we have got 0.001 kgs of salt, and which goes with what? 2 times of 0.02 kgs of water. Then here the ratio of salt and water should be equal here, because there's perfect mixing. So the solution was thoroughly mixed. So which means if 0.001 goes with this, here we've got 3 times this amount. Meaning to say we also have to have 3 times the amount of water. So here we should have, if we multiply this by if we multiply 0.2 by 3, because that's the ratio of it. So which we have 0.006 kgs of what? Sorry my friends, sorry, it should be 0.6 kgs of water. Yeah, sorry my friends, that's the water amount here. So now for the water balance, now it's now easy for us, because we know that water only enters here and leaves here through the overflow, and also leaves here. Here we've got no water. So now how much water is? So now H2O, I want to make it H2O. So we've got H2O entering. We've got 0.2, which comes from the underflow, plus 0.6, and this is 0.8 kgs of water per second. So we've answered our question. Hopefully you like the answering technique. Thank you guys. Goodbye.